So in our final unit, or our final lesson this unit is going to be on solving radical functions. Rational. I keep saying rational. But solving radical functions. In order to do this, it's very, very similar to just solving a regular equation. But the first thing that you always want to do for this, and we're going to just start straight with an example, is you want to isolate the radical. So what I mean by that is anything added or subtracted, anything multiplied or divided to it needs to be moved to the other side. So we're going to isolate the radical. In this case, I'm going to subtract 3 from both sides. Now remember, I can't change what's underneath the radical, but I can get the radical by itself, and that will have successfully happened here. Now, I can just square both sides, because remember, my index, if I square it, then that would give me, that would cancel out my radical. And what I do to one side of the equation, I have to do to the other side of the equation. So I have the square root of 2x minus 3 squared is just going to give me 2x minus 3 is equal to, and in this case I square both sides here, 25. Now remember, if you square root both sides, you have to do plus or minus your answer. But if you square both sides, you can leave it. You don't have to do plus or minus your answer, because your answer is always positive when you square it. So I'm going to solve this for x by adding 3 to both sides. If I add 3, I get 2x is equal to 28. Divide both sides by 2, and x is equal to 14. Now here's the problem. With all radical functions, you must check your answer. So what does that mean? That means take the original equation, 3 plus the square root of 2, and we're going to plug in my answer, 14, there, and we should get 8 from this. So we want to make sure it equals 8, okay? Now, 3 plus, if I do this, I have 2 times 14, which is 28. 28 minus 3 is 25, so this is 25, square root of 25. Simplifies to 3 plus 5, which equals 8. So therefore, my answer is going to be 14. Now you have to check your work. If you don't have an answer that works, then you have to throw it out, and you would have no solutions there. And that answer thrown out actually has a name. We're going to talk about that real soon. Okay, so hopefully that helps, and hope you feel good about that one. Let's do another one. I have 3 times x plus 1 to the 2/3 power is equal to 12. So now we're bringing in that rational exponent that we talked about in the last video. For this one, we're going to divide both sides by 3 to get rid of that number on the outside. I still want to isolate the radical. Even though it's not a radical, I still want to isolate it. So this is going to be 4 over here. And now, instead of changing this to a radical, I could change it to a radical, but I could also raise it to a power that will cancel out that power. Now remember, when you raise to a power, you're multiplying. So if I want to cancel the power, I need to multiply by 3/2 instead of 2/3. And that's going to be on both sides. Now, because my index here, ready? My index is even. So you need plus or minus your answer. Okay? Only if it's even. When you're taking a radical or a square root or anything like that, and this is considered a radical because it's a rational exponent. Remember, it can be thought back and forth. You can go back and forth for it. So when your index is even, you want plus or minus your answer. So whatever I get over here, it's going to be plus or minus, and then my answer. So if I cancel these cancel out. I should just have x plus 1. And then over here, I should have, and I'm going to change it back to a radical, the square root of 4, and then let's put that cube on the outside. Now I have x plus 1 is equal to plus or minus the square root of 4 is 2. 2 to the 3rd power is 8. So now I need to solve. I'm going to subtract 1 from both sides. This is going to give me x is equal to plus or minus 8 minus 1. That's two answers here. You have a positive 8 minus 1, and you have a negative 8 minus 1. So I have my first answer is 7, and my next answer is negative 9. You do still have to check your work for this, okay? So the problem is that sometimes it works, sometimes they don't. So just because we have them as answers here doesn't mean they're going to work in the problem. So what we need to do is we need to take and check our work here, okay? And that's what I'm going to do in this next little part here. So to check it, I'm going to check x equals 7, and that's going to be 3 parentheses 7 plus 1 to the 2/3 power equals to 12. 7 plus 1 is 8, that's 3, and I'm going to go ahead and change it to a radical, the third root of 8 squared. This is 3, the third root of 8 is 2, 2 squared is 4. Now remember, do exponents first, so 3 times 4, which does equal 12. Okay, so that first one checked out. And all we entered was we changed x to be 7. Okay, so now let's check x equals 9, or negative 9, sorry. That's 3 negative 9 plus 1 to the 2/3 power. This is 3, the third root of negative 8 squared. Okay, so this is 3 negative 2 squared. Third root of 8 is negative 2. Negative 2 squared is, once again, 4. So we get 3 times 4, which does also give us 12. So we plugged in negative 9 for this one. So both work. You have negative 7 that checks out, and you have negative 9 that checks out. So those are your answers for that problem. Okay, so let's do one more type of example and see what we get for this last one. I'm actually going to do it on the next page because this is kind of it's going to be a little bit of a longer problem. But I want to show you another type of example. So let's say I have the square root of x plus 7 minus 5 is equal to x. So this, I'm going to add 5 to both sides, giving me the square root of x plus 7 is equal to x plus 5. Now I have to square both sides, okay? So to get rid of the radical, I'm going to square it, raise it to that power. If it was a cube root, I would cube it, and so on and so forth. And then I get x plus 7 is equal to x squared plus 5. Now this x, or x plus 5 squared, I'm sorry, x plus 5 squared has to be expanded and FOILed. Don't forget that. Okay, so we're going to distribute that x plus 5 times x plus 5. That gives us x squared plus 10x plus 25 equal to x plus 7. Now I'm going to move everything to one side and factor. Remember, this is a quadratic, so now you're going to have to solve it like you would a quadratic. Remember I told you factoring in every unit? Here it is. So this is your day where factoring kind of comes back. So we're going to move everything to one side. This gives me 0, set it equal to 0. I get x squared plus 9x plus 18, and I'm going to factor it. Factors of 18 that add to 9 are 3 and 6. So I have x plus 3 and x plus 6 here. My solutions are going to have two of them, x equals negative 3 and x equals negative 6. And then we just need to check them. Both of them work. I'm going to plug it into the original problem. The negative 3 plus 7 minus 5 is equal to x, which is negative 3. So remember, you're plugging it in for both x's. Negative 3 plus 7 is 4. Square root of 4 is 2. So 2 minus 5 does give me a negative 3. So now let's check negative 6. Negative 6 plus 7 minus 5 is equal to negative 6. Negative 6 plus 7 is a 1. The square root of 1 is 1. 1 minus 5 is negative 4. So notice that these are not the same, so this actually did not work. Okay, so one of these solutions is true, and one of them you have to toss out. So we have to toss out negative 6. This is called an extraneous solution. Now, the reason we call it extraneous is because it does not work in the problem. It is a solution that you get that actually doesn't exist, okay? So that is one more of these examples. I do actually have one more. I lied earlier when I said this was my last one. So I want to go over one more little thing, but that is how you do a problem like this. It's a little bit longer. Make sure you check them because some of them will give you solutions that do not work out. X plus 2 plus 5 is equal to 1. Okay, so you can go through and solve this all day long. The first step is going to be to subtract that 5 to both sides, and I'm going to get the square root of x plus 2 is equal to negative 4. I can automatically tell you right here that this will not work. Hold on one second. Sorry about that. Okay, so this will not work, and that's because an even radical will never equal a negative. I can automatically tell you right here, if I have an even index, it's never going to equal a negative. And for this one, there would be no solutions. And you can go ahead and solve them and check them, but they will not work. Okay? So, just to give you like a little bit of a sneak peek of what you might run into. So if you ever get an even radical equal to a negative, just a negative number, not an x or a negative x, if there's an x in there, it's not going to work. You're going to have to solve it. But if it's equal to what happens, so you can automatically say that there are no solutions. Okay, hope everyone has a wonderful day.